And this presentation will be from Piotr Kałuz from Allegro. And he will tell us a bit more about leveraging possibilities of LLMs and generative models in creating MLOps solutions. So thank you, and floor is yours.
Thank you very much, and thank you for a great introduction. And so I'm really happy to be here. And secondly, I want to tell you very little about myself. So basically, I've walked a full path. I was a student in R&D. I was data analyst, data scientist. I'm now a senior machine learning engineer at Allegro. And I have a pretty, I would say, applied science focused background, which gives me a very specific approach to that, meaning I would like to code. Most of the time, I don't have as much time to code as I would want. And there are no machine learning principles in Allegro. So I also do a lot of stuff with management and telling what to do and how to do some approaches in machine learning and in Gen AI and all of those things. So I like to keep things simple, and I like the solutions to work as simple as possible. If you can replace an ML model with a heuristic or with a simple if, do it. And that's the one thing that I think is good. If you cannot, then well, you need MLOps. And so what I want to tell you is we've came a long way, because I've been doing machine learning and stuff for about 10 years. And do you know what is there on the image? Okay, so I see some silent nodding. This is regression, more or less. And we've came to, there are a lot of facts about linear regression, how to build it. You can build it by hand, by multiplying the matrix, and do a lot of cool stuff with it. But in the end, we can get it working in maybe like 4 lines of code, knowing that we have it prepared. With some things like fast API, we can make it work on a server with like 16 lines of code. And this is what I think MLOps and doing ML is going for. So we are having very complex models. Actually, regression is not really that simple if you go into the maths. There's a lot of banking and finance places when it's still used, but we are doing it with 4 lines of code. So there are more complex architectures. There are transformers, and they have been a lot of hype. And how the deployment changed? Well, it can be 3 lines of code in some cases when you import it well. So in some cases, we are going for a simplification of going with an AI. And I think it ties very well to the previous presentations, because we've been going from code to projects. And I'm offering you a bird's eye view on how actually use ML and how probably we are going to use it in companies in some times, and how maybe we can adapt some of MLOps practices for new things. So in a standard approach to ML, at least what I've been doing for a lot of time in my life is some classic problems like, well, we need an ML algorithm, mostly binary classification, maybe multi-class classification in some cases. We have some budget, some annotations in a production or large scale, or want some POC. And yeah, we have some data here in the table. So this is like the basics of machine learning. You have a problem, you have some data, maybe some annotated data, and you make a solution. And in this case, well, there's a thing I've found in old and forbidden books called crisp data mining, and there's also a version called crisp ML, and I really like this picture. It's very old. I don't know if it's older than me, but that could be, or very similar. But there's actually an approach from understand the business issue, gather some data, do some analytics, make a model, and deploy it. And we've been going with a lot of approaches in MLOps on how to do stuff and how to do the deployment part, how to do the monitoring part. But in the end, we are all creating solutions to solve some issues. So this still applies, I think. And I use it because it's really easy to think about it. We have a business problem. like classifying frauds or fraudulent transactions, for example. We have some data. We need some collections. We have a database of frauds. We have some client data, some data about what they bought, for example. In case of e-commerce, we do some data collection. Then we do some statistics, some cleaning, some data mining. Somebody is evaluating a POC of the model. We are using a ready solution. This is mostly the job of data scientists, and we are deploying it. And in deployment part, well, there are a lot of ways. We can do standard API, we can do batch, we batch daily, batch like we've seen with the fast API to optimize the requests, and we need some data drift, error monitoring, and so on. And the red part is mostly what's considered to be MLOps, but a lot of things needs to be done to actually make the blue part match with the red part. So they need to work in tandem. And actually, most of the time to retrain or do it, it also needs to work with green part. So we need to use the same data to actually make it into a workable, retrainable pipeline. So the previous case was pretty easy, but I don't know if you experience this. I experienced this for sure. There's not a question of let's build an ML model. There is a question of, okay, so we need to know what colors those objects on the photo have, and can we do object recognition for 20,000 different classes, and yeah, add OCR to that, and some language recognition, maybe named entities. We need segmentation for sure. And does this text have some kind of explicit content on the image? And can we make like some maybe descriptions for the images? Can we use Gen AI? And so on. And this is something that I deal with day to day. And all of those things are important because they all might solve or might actually solve, if they're profitable, a business issue for your company. But how many of you actually in terms of ML feel like there is always a lot of work, too much work, and you feel overworked with those things? I can safely raise my hand in this. So I feel like there's always a lot of things to be done when I work in ML, too much things for my time. And based on those previous models that you could save easily, you have now a lot of issues like GPUs, and maybe we need to use some classifiers, we need to check the classes, we need to build some evaluation tools for them. How to even evaluate like segmentation models? What really is the business case? And are all those labels even okay? For example, like Google has a vision API that does not explicitly say what labels are on the images. That's really helpful, right? So this really helps you in the way of evaluating those solutions. And there are a lot of different models for text classification, sentiment analysis, and there are the Tectrons, the YOLOs, the ResNets, the Dinos, all things that you can think about, and probably would rather think of the Dinos not in terms of machine learning. But there have been something new, you know? So there have been some models that you can call and say, well, count the number of people on the image, right? And most of you would say, like, you're crazy, man. You want to do like ML with this? This is costly. Well, it depends on your case. Those models can, in some cases, answer the business questions that have been the basics of actually using ML. Like some heuristics can be used, like very simple models. LLMs can also be used to answer the question that we have in machine learning. And there are, in some cases, and I'm going to say it very straightforward with you, in some cases, they might be the solutions. They can count people, they can count objects, they can differentiate between things on the images, they can list the number of ingredients that you see on the image, so basically they can do classification maybe, and they can do OCR on very different kind of like text that normally wouldn't be recognized easily by the OCR. And there are a lot of other cases that you can do with LLMs like this, even with the commercial ones. So, for example, I have a problem. I want a lot of information in my domain. I want to see, or maybe not I want, but many of stakeholders want to see how many objects are on the image, what is the main color of those knives here, and what are the other colors from the materials, and what category in the e-commerce, for example, or what type of product in e-commerce is this, and is it a set or a single product? And give me a rough estimation how much do you think it would take, how many people working for how many time it would take to build models for that? Like a year. Whoa. Yeah, maybe for you, maybe for you. For normal people of us, like 3 years, and give me a team of 5 people. With evaluation, scaling up, no way. Like I would say maybe 2.5 years for me would be a reasonable approach. So I asked a model. I asked a Gemini Flash, the cheap one. What is this? Well, this image shows 5 kitchen knives. There are 5 objects. Well, they have a main color, silver, and a material, stainless steel, black handles, right? They are kitchen knives. They are a set, yes, and they are from Gerlach, by the way. So when people come to me with some business questions, this might be the answer. Well, if you have 10 billions of images, maybe not. If you are building a solution that's general, maybe not. If you are doing research, maybe not. But if you're solving a business issue for a client, maybe that's a question. So how much does it cost really? So I've used a generally available pricing model, and I've made some rough estimations that, judging there are 450 tokens in the prompt, and I checked that, there will be about 550 tokens in the output. And as far as I know, Gemini also, you need to pay per image additionally. So for 1,000,000 images, it's $80. So if you have only 1,000,000 image in your use case, you can decide 3 years in a machine learning team or $80. So yeah, let's be realistic, right? In some cases, it might be good. It might not be perfect. And there are a lot of issues with that. And one of the issues is this meme I found, and it's really good. So it's about actually providing the output for the models. I've actually written a reverse lookup regex for catching the invalid JSONs. And I can do this. I'm not crying that much because I can do the reverse lookup JSON. But it's not really, not really so easy, right? You need to work on this, but this is still not 3 years, right? And 5 people. This is basically, this is outsourcing something that is hard to get, meaning ML knowledge, to a standard software developer. I can say to you, bro, validate this. You need to parse this. And maybe this is cruel, but this is resource efficient in large organizations. So how good are these models, right? So I asked the cheapest one to describe me this image. And I'm not really a specialist from hardware, right? But this is a laptop motherboard. It read the model. It gave me a good long description of all the parts. I can't even verify some of them, so that's good. And there is also a Dell logo clearly printed on this board. You have a very sophisticated computer vision task that requires a specialized knowledge from hardware. Maybe just take 20 research engineers, or maybe pay $20. So in some cases, we need to think like this. So to not be overworked, to actually give business estimates. This is not the most efficient solution. And I feel like from the meme, they all hated him about what he was saying, because that is like that. Because if you're doing cool research, you don't want to be replaced by an API call. If you are doing a very sophisticated computer vision pipeline, you don't want to be replaced by an API call. But in some cases, well, you can be the first one to automate this, and well, these descriptions looks good enough for me, will probably look good enough for business. Or you can actually translate computer vision task to a more, maybe easier to some people, natural language processing task. So, but I don't want to pay some cloud company. Use Florence. It's new, it's nice, it nearly does the same, and it's on open license. You can check this if you don't believe me. You can use Llamas, Bielik. I mean, just try, just have fun. Just solve your business case with this. Do image captioning, object recognition, and so on. And but man, the code can be really, really hard. Well, it's not. It's actually the code call for this kind of thing, and I can safely say to you that junior analysts with some Python can run Gemini calls on batch requests for million requests, the good ones at least. But this is the level. So we can run 10 million requests easily with batch API, of course, by script, of course, by Jupyter, of course, by setting some edge cases, but you can easily automate it. So this is not really that hard. And in some cases, it may solve some issues. So, but how exactly, what problems are we facing in terms of machine learning issues? So for example, a different case is sentiment classification, right? Is good, bad, positive, negative. So normally how we would approach this is to have a database of some comments that we have some ground truth for. They have been annotated like positive, negative. We can do some edge cases cleaning, like different languages, maybe some heuristics to filter out the too small text, too big text, have some sentiment classification model, big one, small one, my own one, deploy it on some platform and monitor it for data-driven errors. And I asked myself, okay, so this is a standard pipeline, right, of NLP processing. How would it change with the use of like LLM? So yeah, so we classify sentiment, we have a database of exactly the same ground truth. We do the same cleaning, heuristics, and well, we change one black box, meaning the sentiment classification model, for second black box, meaning our LLM, for example. And there is also one thing that's very important. We need output validation if we have some fancy output in there. So we need a little more work to do from the MLOps side. But the good thing is that it probably is going to be some generic issues that more or less later are going to get some library for that. So maybe you see something that I don't. I've been trying to work with business on those approaches, and they are not really that different from managing perspective. Like maybe, yeah, there are some other cases. For example, let's classify objects on the image. So do like classification of like 1,000 classes from the image, computer vision. So we need a database of annotated or ground truth classes for those images. We need some edge cases, cleaning, heuristics, and we can have an LLM for that. Output me the images with the labels or maybe some probability. I wouldn't trust the model to do this, but maybe you can check if it makes sense. But overall, we are not really interested in probability that much. We're interested with acceptable results. So if the model brings you enough accuracy or precision that you want, you can just use it. Why not? You cannot cut it after like 0.9 prediction. Yeah, but if it fits your business criteria, that's good. So for me, this also doesn't change it that much. So if I need 1,000 classes, I need 1,000 ground truth labels for some tests. And I can run it by any model, including a call to an API, and process the results exactly the same as I would from an LLM or like API model. So there can be some questions. I predicted that. So, but those, Peter, those models are random. They're unpredictable, right? Yeah, human annotators are unpredictable. I work with annotation on a large scale. Human annotators are as unpredictable as those models. Trust me on that. So the data drift is also unpredictable. So you train a model, it changes. So yeah, that's also an issue. And in case of LLMs, this is an issue. So you also need to observe that. So it doesn't matter if you use your own cool computer vision model that you've stacked here with the version 0.5, or you are doing the next API call to an LLM. You need to watch for the data drift altogether, all the same. And we all need to measure that kind of errors. So that doesn't change that much if you are going by the book. But well, we don't know how they work. How do they get those predictions, right? I can't, there are no explainability in that. Well, I had a lot of issues with explaining computer vision models or any like BERT models or anything like that, or any NLP models to business. This is just very hard to do. And there are some cases when explainability is very much needed, but in case of like computer vision, like, is it a cat or why it's a cat and not a squirrel, right? Right? And you're going to explain it that, yeah, you see, so in the left upper corner, there have been some pixels that say that this is probably not a squirrel, and hence the classification results. It's hard to explain that to business, you know. So maybe if you get the results by an LLM, you can just use that, right? So you don't know how. I mean, you know, but to some extent how LLMs work, because you don't. In some cases, you may not have, you know, all the weights, all the explainability, but so is for a lot of computer vision cases, for example. And well, there is one thing that I agree. There is no good MLOps software for LLMs. And you may say, well, but there's LangChain. There are a lot of cool libraries. There are like 55 prompt libraries that use cloud to store 20 strings from you. Yes, they are, but they're not really good in a lot of cases that I'm showcasing here. So there is also one thing that you can use LLMs for, and this is called, from the research perspective, LLM as a judge. So you can, for example, build an annotation pipeline with an LLM. So you have some data. We need to build an annotation database, and you will have some maybe ground truths from humans in some cases. You do some edge cases, heuristics, some cleaning, some data mining things, and you have multiple prompts that give you the annotation results for those type of data, like image data. You can even train this thing on the annotation database on an LLM and build your own model. Well, there is a bias in that. Yeah, sure. So hence we have the annotations, we monitor the results, we cross-reference, we do cross-validation, we have some kind of human annotation, because there is bias in that, and there's bias in every ML model, I would say. And this is, you will see this a lot when you hear to people from banking, finance. They all need to account for bias. So we also need to account for bias in this case. But this is very important because it allows us to work a very quick and large solutions in cases that don't need 99.9%. So there are some papers for that, like from June 2023, then some of 2024, and really interesting. They're building some approaches to that, and they can solve a lot of very large business cases because if your company didn't have to pay millions of dollars for annotations, or it already did in some cases, well, we are actually using the annotations that they paid for in like OpenAI or Google, and we are reutilizing that more or less. So, and one thing is, I cannot guarantee to you that if you pay $5 million for human annotations, the quality is going to be better than LLM. I cannot also guarantee you it's going to be worse, right? But take into consideration that we often consider that the data that we built our models on is actually good. It have been validated. And it's often not the case. If you never trust your data. Like, I don't know if you remember from research, but they have been this MNIST data set of numbers, the most basic ones, and have been like 5 papers showcasing that there are some hard, like edge case results that have been misannotated in this data set that you could check in one workday. So imagine what happens on not really that good data set that have not been evaluated by thousands of millions of people, or your internal systems in your company. So there are a lot of techniques to actually make this work. There is basic prompting called like zero-shot prompting. So you give them all some background. You, for example, having the following article text in a media outlet, please categorize it as one of the following. And you give it, you just give it a list of categories. You can parse it directly from your nice Python code. And you have some data that the model is going to decide on, like the title, on the content, and you can see on the right how it looks. And so basically, they are approaches to improve that, to give it some context. And this can be called like one shot, some kind of information that the model is given that helps it undertake the decision. So for example, for this title, the category is sports, because you often know that it makes mistakes in this case. Or you can give few shots, so a few examples, and it works astonishingly well in some cases. So you can give some examples, put it into the prompt, and the model performs better now. So there are a lot of cases when you can use those techniques. You can read a lot about them. They, like, if you remember, like Bitcoin craze, there is now LLM as a judge craze to some point. So you'll find a lot of cool articles about that, mostly generated by AI. And in those cases, that may be interesting for you. But how can you use it for? You can use it for scoring. I've not really worked with that, to be honest. I've not worked with LLM scores. Like give me something like a prediction score. I've not worked with this, so you can test it yourself. I worked with providing explanations for the annotators to catch errors, to catch the patterns and how the AI behaves on some data. So explain to me why you classificate it is as X, and the model gives you explanation, and you can then use it to, for example, improve the data set or improve the prompt. You can use it for scoring with reference. So for example, you can give it some reference data. You can use pairwise comparison, like judge which LLM output is better. And this is actually the base approach of LLM as a judge. And you can also use it for ranking. You can use embeddings, or you can just ask an LLM. And how do I know that? Google actually did that in one of their like core approaches to their new like experimental AI services. So yeah, they do this. And you can use it as an agent or voting models. There are a lot of, in 2-minute papers channel on YouTube, there are a lot of cool cases with using LLMs as agents to have different roles, and it actually works in some cases. And I've given you a lot of information about like the internal workings of those models. This is more like a data scientist job, right? No, because we don't have actually code for that. We don't have pipelines. We don't have good prompt management tools. There are not a lot of approaches to make like agent or voting models good, or to make a feedback loops for that. And this is the area that I think is going to jump a lot in like year or something. Also, I wouldn't trust an LLM alone. Having some human annotation is always good. You need some human sampling, like sample checks. And in some cases, LLM might be right and people might be wrong. And in other cases, the people might be wrong and LLM might be right. And you need to consider that in your pipeline. There are also other approaches, like you can do chain of thought, like explain it to me in steps, validate this, validate the output. For example, do a lot of stuff. Do the approach step by step. And why this is important for MLOps? Because you need to build this. You need to validate this output 3 times now, and you need to know, have some metrics to knowing if it's okay, or maybe just focus on the final one, but still you need to make a few calls. Maybe you need to make like a list of steps in the pipeline that's depending on the previous data. So that's actually challenging. You can also decompose the problem. So you can have an independent LLMs working on solving the issue in some problems, because if you ask LLM for a lot of things, they're going to be more wrong, but also check that for a specific issue. So you can decompose the problems. So first of all, classify it, then tell what is the language of this article, then, for example, provide a justification of why it's like that. And there are also RAGs, there are external APIs to use, and you can use internal company APIs, external APIs. You can tie the query to some real-time answers from your database, or you can ground the answer from some kind of data that you have. Well, is it ML? maybe it's MLOps, maybe it's just ops or software. I don't know actually. So this is kind of tricky for me because a lot of people in MLOps are doing like RAGs, and I don't know. It's actually very close to software, right? In that regard, it's very software-like. So people think that ML works like that. You just write some code, you run some code. In reality, the standard ML runs like you need to acquire and experimental data like 80% of the time. And now what we need to do is acquire experimental data and test the prompts for 80% of the time. And if you want to know how to actually make this work, I've stolen this image from Data Science Dojo. I think it's cool. I really like it. So you define the use case, you choose a pre-existing model, you do some prompt engineering with those examples that I give you, some fine tuning, you align it with some human feedback. You can be human, you can check some kind of answers, you evaluate it with some metrics, you optimize and deploy the model, or you just, optimize your endpoint from the API, or build some pipeline if you need some more advanced answers, and you augment the model and build some applications with that. So to sum up, what are the biggest challenges of that? So first of all, from my perspective, cost versus feasibility versus effect. What is the problem that you're trying to solve? Is your problem we need an ML solution? Is your problem we need an own ML solution? Or is your problem we have too few software engineers or ML engineers and we just need it to work? So in that cases, it's always pay up or either for FTEs or for the solution. There are a lot of cases in the legal, especially in terms of like AI Act in Europe and the areas of use. There are some cases in which you could not really do that without a lot of working on evaluations. You need some human in the loop. You need multi-criteria annotation to do it good. So you need to actually have a way of validating the output that the model gives you or justifications the model gives you to have some kind of good answers. There's not really an explainable AI for this, but there's also not an explainable AI for search engines, for embeddings. So there's that. And in MLOps, I think the most that is needed is data validations like unit tests, because, well, LLMs are unpredictable. They can give you stupid answers. So you always need to have some like unit tests for some input to check if it didn't get stupider over the API over the week. And you need some pipelines for data validation, output validation. You need some new metrics, for example, for hallucination. You wanted to shorten the text. So how many new words appeared in this text? So this is a new cool metric that you can use. And maybe show on some dashboard for some people to judge if it's okay or not. You need some ground truths, and you need some probably outlier detection, but you can use embeddings. Those GPT can provide embeddings for you out of the box, so maybe you can use that. And for me, it's always have been like this image. Either build something that works or do like very complex machine learning pipeline. And it's not that I haven't used, I've deployed a lot of machine learning pipelines for billions of predictions, for in a lot of cases from small one POCs, but the end problem is always like, how do we get this running on production? And if you solve this issue earlier and don't need research, you just need a POC in some cases, I think the LLM are going to be easier. And I think there's one thing that's going to be significantly easier with LLMs. It brings the use case, the first things, much closer to the business. Because, for example, not a lot of people from business can understand how classification algorithm works or like how BERT works, right? But a lot of people from business can write a prompt and judge if the answer is okay or not. You can have it in your Excel spreadsheet with the input, with the output from the LLM and tell them, okay, so tell me if it's okay. And if we can run it. You can outsource testing the prompts to people that have completely, or maybe not completely, but have the business knowledge and have no technical knowledge. So you can build platforms for people to check the prompts instead of doing this yourself or overworking yourself and the data scientists. And there's more. There are image pipelines. So there are also Gen AI models. There's stable diffusion. Maybe you want to try some new clouds. I think I know some people that have actually worked with this, and this is also a challenge in a similar way, because we are actually need to now not validate the text or annotation, we need to validate the image. what are the metrics to validate quality of an output image? And I leave it that to you. And we can use LLMs in a lot of ways, as NLP, conversation pipelines, as classification tools, especially for images like computer vision, like YOLO or similar models. I've had a lot of success using Gemini, for example, for that, as an annotators, as validators, as recommenders for other LLMs. And we can use other generative models for example, image generation for image edition, and also to use as a validation pipelines to some kind of image edition. And should we abandon traditional ML models and pipelines and development on all the research? No, this is all just ML is here to solve the issue for the company or to make it fun for you. So if it's fun for you and it also solves the company issue, it's great. Do you need to use LLMs and Gen AI? No, but somebody will probably. And just make sure you win this argument, or you win or you know your enemy if you don't like them. And so what do I think we should do? We should just consider them just yet another black box ML model. And I think if we go with that, we can actually have some results. And thank you very much.
Thank you very much. And are there any questions?
Yeah, I have a question about actually how much time does it take to run, for example, one of the kind of, let's take this example of those knives that you had this picture with knives. I understand that price maybe not that high, but probably it takes like much more time for the model to come up with the answers comparing to some other solution, I guess. So as number of new images every day or every like time span grows, it may turn out that actually it takes more time to classify that than actually you have during the day, right? So have you encountered this kind of problem?
Yeah, it all depends on the scale. So for example, I tie it very good to the cost versus effort. So for example, if you have like a few million of observations or images, this is great. LLMs are just fine. If you have 5 billion of examples, maybe not that much. There are a lot of I think there have been a lot of development with batching from both OpenAI and Google from GPT. Sorry, from GCP Gemini that I've tested. So I've tested both the Azure version of OpenAI and the GCP, and they are both really efficient at providing batch predictions for large scales of data, and also batch predictions are cheaper than AP code, so there's added benefit to that. So if you need data daily for like dumping the results, this can be doable on a large scale. If you want to pay a lot of money, this is very doable with GPT, as far as I have a pleasure to work with their API limits. They're very forgiving, and you can put the slider to really have a lot, but you pay for it, unfortunately. So Gemini, I would go like this. If you need to POC something, test it on like Gemini, maybe Flash, it's very cheap. If you needed something more, test it on like GPT, maybe Mini. And maybe if you want to scale up and you don't need very sophisticated answers, you can try like self-hosted, like Florence. It's really giving a pretty good results and has a Docker image. You can try that on Hugging Face. Maybe this solves the issue. But from my experience, like of course, like GPT gives the best results. Then there's Gemini. Then there's GPT Mini, and then there's Florence. I think from that regard. But it depends on the case. If your case is simple, like for example, I thought about like giving you the character from the text, right? Is it a movie character or not? So that probably, I think the models could actually do that. I'm not sure, but you can check.
Great presentation, thanks. I have a question related maybe to the deployment part of it, or in general, what would you say to the business if you are building LLM-based solutions? And if you are using either Google or OpenAI, the more products you build on top of that, the larger the impact surface is for the single point of failure being API calls to some third party. They can, for example, turn off some model at any point in time, and the more products you build, the more doomed you are. So what you are saying to the business?
So that's a really good question, and I've answered it a lot, and I always answer it depends. But to sum it up, basically it depends on your case. If your case is actually focusing on a constant deployment, this is a risk. Maybe you need to have like some backup, or maybe you need to use the LLM because it's fast, because you can develop it fast, because you can build a solution, and then think about if the company is really scared about the risk or the performance dropping, then you can actually build a second solution like in-house model. The question is, it all depends. I think risk evaluation depends on the approach of the company. For example, if you're working for a company that's on the market for like a few years or maybe up to like 10 years, they might just not consider this risk. But this is also, if you're an owner of this company, you need to consider it for sure. I would say that there are risks, like with everything. But I think the biggest risk is the risk of failure. So the risk that I am the most afraid of, from the perspective of actually talking with a lot of directors that ask me the exact same question, is what is the risk that we are going to spend 3 years or like 2 years of research and then a year of actually building a pipeline or a platform that nobody is going to use. And after 3 years, we are going to sink like $500,000 and we could do this for like $5,000 by Gemini. So for me, like with all business things, this is cost versus effort versus risk. And I would always say that having a good research team building the same solution that we've just stolen from the API is a great approach, and I think is the most cost-efficient approach, because we already have ground truth, we can check how it works, and we can try to mimic them while we also check if the new version is better. So this is risk mitigation, I would say, the best one in this case that I thought of.
So great presentations, and I have two questions. The first one is about creating annotation, data annotation with LLMs. And I'm wondering if it's possible to use data generated, for example, by a GPT model for creating your own model. As far as I know, there were some limitations about that. And how does it look now?
Well, I'm not a lawyer, so I can say that it's probably says something like, we do not take any liability for any models that you create with the data generated by the use of Gen AI, as this, and so on and so on. So that is one risk. The second risk is actually the legal part from AI Act and some cases. For example, if you work in healthcare, forget about this. Maybe you need some specific case of I would say, explaining some descriptions of OCR. You could probably go with, we have nothing better, and this just performs better, and have some metrics to give to business. Same with like finance or some approaches. I would say that, for example, yeah, there might be some information that you may not use the like those annotations to building your own model. So, for example, you could use a local LLM that does not have those limitations. So that's one approach. Second example, maybe you are just using it to validate some human annotation. This is also a valid case. I found it that those models tend to be very good at catching mistakes, especially when people annotate images. So this is the second case. So my quick answer, consult with legal. My long answer, there are approaches to actually mitigate that to some point, to be sure, right? Especially in Europe with the AI Act.
Okay, thanks. And the second question, as far as I know, Allegro tried to on new regions with internalization. And regarding that, do you know how those models perform on other languages than Polish, for example, in Czech?
I would say that what I observed and confirmed is that those models work really well even with mixed data. So to some point, how they build the embeddings is language agnostic to some point, I would say, the idea behind it. It doesn't work perfectly, but you could use those models, especially in cases when you have mixed languages or you want to do generate some things in Polish, for example. It's really good. As to the large scale performance, I cannot say. Both from the legal standpoint and from the fact that exactly there are hard things to answer because they depend on the case. And I would say that what I observed is, for me, this is a fresh thing using LLMs in such a case. And for me, this is treating them like a magic box, like we're going back to the black box approach. And there are a lot of, I would say, challenges in actually qualifying the error rates in your case. And without this, without due diligence in knowing what is the risk, what are the error rates, and how can we mitigate that from legal perspective and from the model quality perspective, maybe we can do some checks. It's hard to answer. It's the same like you would not deploy a model without checking the precision. So hence you would not deploy an annotation database, for example, without checking the precision or having some approaches to validate the predictions or what the model is producing. And this is a huge challenge, I would say, in MLOps, because, for example, if you want like image to text, right? The image to text have been in the research for at least like 10 years or more, I think, and there are still not a good pipelines to actually validate like image captioning, right? So it's hard to do because you need to work with images, with text. So there are a lot of cases, and I think what we are far behind in terms of capabilities of validating those models. So we've been focusing a lot on binary classification and just classification. We did some infrastructure to actually enable those calls or enable the prediction or inference, but we don't really have good tools for monitoring and evaluation still, I think.